Welcome to lecture video series Renewable Energy Resources Module 2 Solar Thermal Energy Collector. So in that today we are going to see concentrating collectors. So concentrating collector, we have discussed in previous class what is collector, what are the types of collectors. In that first one, flat plate collectors we have seen in the previous video. This video we are going to see the concentrating collectors. So concentrating collectors is nothing but it is not a flat surface. The surface is like a parabolic or cylindrical, or it may be evacuated size. So usually they have concave reflecting surface to intercept and focus the sun beams radiation to the small receiving area. So a small receiving area is very small, but it reflects over the surface and it will be reflected back to the small area. That is, we call it as a parabolic type of collectors are coming under the concentrating collectors. So by increasing the radiation flux, or we can say that concentrating solar collectors use shaped mirrors or lens to provide the high temperature than the flat temperature. For wherever high temperature is required, there we can go with this concentrating collectors. So collectors are used to absorb the solar's energy into heat energy, converted into heat energy. Wherever your temperature requirement is less than 100 degrees Celsius in the sense, then we can go with the solar flat plate collectors. Wherever the temperature is more than 50 to 400 degrees Celsius in the sense, we can go with the parabolic concentrating collectors. And if the temperature you want more than 400 degrees Celsius, or you want 1200 degrees Celsius, 1500 degrees, 2000 degrees Celsius in the sense, then we can go with the heliostat collector. There also the concentrating collectors are used. But the thing is, any concentrating collectors have some drawbacks. If I are using concentrating collectors, that means parabolic collectors in the sense it requires mirrors. That is glazing material. If you use mirror, the mirror surface should be a clean one. It should be reflecting surface, that it should be smooth one. If any dust materials or dust particles scattered in the sense, the light cannot be received properly and it cannot be absorbed by the absorber. And smooth surface should be proper, otherwise what will happen in the sense, the contour error can occur. So one criterion for selection of specific concentrator is nothing but the degree of concentration and the temperature. What degree of concentration is required and what is the temperature to be achieved. These two things we have to concentrate while going for the selection of the collectors. The concentrating energy on a point which produces the high to very high temperature. So high temperature to very high. High temperature in the sense 100 degrees Celsius to very high in the sense it may be 2000 degrees Celsius can be produced. That much of heat temperature can be produced if you are using heliostat receiver or heliostat collector. So it depends upon the material, the moderate to high temperature can be produced. Non-focusing concentrators will produce the moderate temperature or low temperature. So concentrating collectors, various types are there and it can be classified in many ways. For example, based on the concentration, there are methods are used like a reflecting type or refracting type. There are two types of the concentrating collectors. Reflecting type in the sense we are using the mirror, and if it is a refracting type in the sense Fresnel lenses are used. That means the beam of light will be passed through the lens. Mirror, if you are using mirror in the sense it will strike the surface and reflecting back. which doubles the solar energy. Based on the reflecting surfaces, in the sense there are three types of the concentrating collectors. One is a parabolic, spherical and flat. And based upon the continuous or segmented, there are two types: continuous concentrating collectors, segmented concentrating collectors. Based on the formation of the image, there are two types: imaging concentrating collectors, non-imaging concentrating collectors. So imaging concentrator, in the sense it will focus on a line or a point, that is imaging one particular point, as like a parabolic dish. The mirrors will receive the reflection, and after the reflection it will point to the center, that focal point. On the basis of collector concentration ratio CCR or operating temperature, we can classify the collectors. Based upon the type of tracking, horizontal tracking, vertical tracking, again the concentrating collectors are classified. So parabolic dish reflector, which uses the point focus operation. Parabolic trough is an example for the line focus optics. So concentrating collectors are available in different configuration. We will see one by one. So this is nothing but compound parabolic collector. So here it is a like small bent. This is a mirror, and center there is a focal point, and here the pipe will be there, the water will be flowing or any fluid will be flowing through this. So whenever the light falls onto this surface, it will be reflected back and it will be absorbed by the receiver, and the pipe, the fluid which is flowing through the pipe will be gets heated. So now the solar energy is converted into heat energy. So this is nothing but concentrating collectors, compound parabolic collectors. It is like a U shape. Parabolic mirrors are fixed in the surface, in the both the sides, adjacent sides. And this is a flat collector, and insulation will be provided. And the sun radiation will be falls onto this middle, center. So compound parabolic concentrator consists of two parabolic mirror segment attached to the flat surface or flat receiver. It has large acceptance angle. So acceptance angle is very large. Need to be adjusted intermittently. Rays in the central region of the aperture reach the absorber directly, where the rays near the edges will go for the reflection and before reaching the observer. So suppose the ray is falling here, in the sense it will be reflected here, then it will be reflected here, then it will be reflected here. Sometimes it may be go outside also. So the concentration ratio achieved from this collector is very good. Next one is Fresnel solar thermal collector. Fresnel solar thermal collector used to generate wherever the temperature requirement is more than 400 degrees Celsius or more than 100 degrees Celsius and less than 400 degrees Celsius. In the sense, you can go with this linear Fresnel reflectors, which relies on the array of linear mirror. So if you see this diagram here, this is nothing but the linear Fresnel reflectors. So reflectors are kept like the array. Whenever the sun lights falls onto this reflector, it will be reflected back, and the top of this kit or this hard system, there is a receiver will be there. The receiver will receive the energy from the solar. So the receiver will not receive directly from the sun. It will be the sun energy or radiation will be reflected to the linear Fresnel reflector, and it will be gathered or collected by the receiver. And whenever the water is passing through this, in the sense, then the water will become the steam. The steam will be given to the turbine. Turbine will rotate, and then the rotating turbine will rotate the generator. The electricity will be produced, and the water vapor is passed to the steam condenser. So the water vapor, low pressure water vapor will be given to the steam condenser, where the steam is converted into water, cold water, and it is again passed. This is nothing but the Fresnel solar thermal collector electricity generation. So system with line structure and low cost technology for this process, and can be effectively produce a heat temperature between 50 degrees Celsius to 400 degrees Celsius. They are made up by bending sheet of reflective material into parabolic shape. A metal black tube is covered with the glass tube to reduce the heat losses, which is placed along the focal line of the receiver. When the parabola is pointed towards the sun, the parallel rays are incident on the reflector and reflected back to the receiver. So sun will be here and parabola will be here. So it will be absorbed and it will be reflected. Here the receiver will be kept. So rays will be point to the reflector and reflector will be sent to the receiver. Receiver will collect all the reflecting signals or reflecting rays. So it is sufficient to use the single axis tracking system, and long collector modules are produced. This is nothing but the parabolic trough solar thermal collector. So it is nothing but a tracking system. Parabolic trough solar thermal collector is a tracking system. We have a tracking here, tracking system is there here. So based upon the angle of the sun, the receiver will be tracked or moved, shifted, not shifted, it is moved. The tracking system will be moved. Here also the pipe is connected in this manner. So sunlight falls onto this mirror or the parabolic reflector, then it will be reflected to the receiver, where the receiver, there is a pipe and fluid will be passed. So here the cold water is passing, here the hot water is passing. That means the steam is water is converted to steam. That can be given to the turbine to rotate the turbine, and when the turbine is rotated, it is connected with the generator and the electricity will be produced. For that purpose we can use this one. So that is nothing but parabolic trough solar thermal collectors. So the trough concentrates sunlight onto the receiver tube that is positioned along the focal line. Sometimes the transparent glass tube also used as a receiver tube to reduce the heat loss. It uses often single axis or double axis tracking system. The temperature at the receiver can reach maximum of 400 degrees Celsius and produce the water into steam for generation of electricity. And next one is nothing but cylindrical trough solar collector. It is the collector is in cylindrical in nature. The focal point is here. So whenever the sun rays falls onto this any surface, that can be collected by this focal point. The linear translation does not introduce any defocusing of the concentrated radiation. So the aperture of a cylinder trough need not to track all maintain focus. So previously we have seen the parabolic trough, it has to focus the sun. But cylindrical in the sense need not to focus all the focal point. Because the cylinder is having high rim angle, which have the focal plan, not focal line, focal plane, not a focal line. The cylindrical troughs are designed with the low rim angles in order to provide the approximate line of focus. The advantage is need not to track the sun in any direction. It will provide the high temperature. Next one is parabolic dish system. Parabolic dish system, it is similar to the satellite dishes, but it has some mirror like reflectors and absorbers that has the focal point. So this is the receiver. This is a parabolic dish system. Oh, this is a focal point. This is a parabola and this is tracking system. So these mirror-like reflectors are there and absorber is there at the focal point. It uses dual axis sun tracking system. So it can move accordingly. It is a point focus collector that tracks the sun into two axes. One is concentrating solar energy onto the receiver. So this concentrated solar energy onto the receiver at the focal point of the dish directly. Second one, the dish structure must be tracked fully the sun to reflect the beam into the thermal receiver. So the receiver absorbs the radiation solar energy, converting the solar energy into thermal energy by circulating the fluid through the pipe. So the solar energy is converted into heat energy by heating the fluid. So thermal energy can be either converted into electricity using engine generator coupled to the receiver, or it can be transmitted through the pipes to the central power conversion system, or it may be used for the heating of the space. So parabolic dish system achieve the temperature of 1500 degrees Celsius because the receivers are distributed throughout the collector field. It's like a parabolic trough, parabolic dishes. It is also called as a distributed receiver system. Advantages of the parabolic dish reflectors in the sense they are the most efficient of all collector system, always pointing the sun wherever the sun moves. Typically have high concentration ratio. That means absorbing and collecting are equal. So because of that, the range of temperature will be obtained is nothing but 500 to 2000 degrees Celsius will be obtained, and highly efficient for the thermal energy absorption and power conversion system in the electricity. They have the modular collector receiver units that can either function independently or as the part of the large system dishes. So this type of solar thermal energy concentrator, which is mainly used with the parabolic dish engine, which is an electrical generator that uses sunlight instead of a fossil oil like crude oil or it may be coal to produce the electricity.